What a wonderful day we have. I'm James Saldana Galda, speaking from Dr. Juan G. Nolasco High School, and I will be your guide for today's lesson. Today, we will discuss about joint and combined variation. Our objectives for today's lessons is number 1. Illustrate situations that involves joint or combined variation. Number 2. Solve problems that involves joint and combined variations with ease. Number 3. Apply this knowledge to real-life situations using the formula and quantities of joint and combined variation. And lastly, know the differences and similarities of joint and combined variation and how to tell them apart. But before we head on to our topic today, which is joint and combined variation, let us first know or review what exactly is a variation. Variation, if your problem states that there is a functional relationship among two conditions, there is said to exist a variation between them. There are 5 types of variation. Number 1 is direct linear variation. Number 2 is direct square variation. Number 3 is inverse variation. Number 4 is joint variation. Number 5, combined variation. But for today, we will only be focusing on our lesson, joint and combined variation, which can be found on page 21 of our math time, second quarter. Let us now move on to the definition of joint and combined variation. Variation may involve 2 or more variables if a certain variable varies directly as the product of 2 other variables. Then it is a joint variation. We can say that joint variation is fairly similar to direct linear variation, where y is equal to kx. But in our situation, joint variation uses 3 or more quantities. However, if a certain variable varies both jointly as a product of 2 variables and inversely as other variable, then it is a combined variation. I have prepared an example to further extend our knowledge about joint and combined variation. Let's now move on to the basic examples. Here's number 1. A varies jointly as D and B. We write this equation as A is equal to KDB. Number 2. D varies directly as P and inversely as the square of Q. We write this equation as D is equal to KP over Q squared. And number 3. P varies jointly as L, W, and A, inversely as V. We write this equation as P is equal to K, L, W, A over V. Lastly, number 4. I varies directly as the cube of S and inversely as X. We write this equation as I is equal to K S Q over X. We must also remember that there are some cases where the combined and joint variation are both used in a sentence, like example number 3. If the example is both jointly and inversely, then the formula most likely has 3 or more variables, where the example number 1 contains joint variation and where examples 2 and 4 contains combined variation. By these examples, we can already see the differences and similarities. Since one of our objectives is to solve joint and combined variation with ease, let's have more examples. Let's have number 1. Let's say that the speed of a car is directly proportional to the number of hours it has been driving and the number of cylinders in its engine. If we denote the speed of the car as S and the number of hours as H and the number of cylinders as 3, we can express the joint variation as S is equal to KH. In this equation, K represents constant of variation. It remains the same as long as the other variables are proportional. For instance, if the car is driving at a speed of 60 miles per hour, after 1 hour of driving with 4-cylinder engine, we can find the value of K by substituting the given values into the equation. This will get us 60 is equal to K times 1 times 4. Simplifying the equation, we get 60 is equal to 4K. The next step will be dividing both sides by 4. So cancel out 4, then 4 divided by 60, which causes us to get K is equal to 15. Now, we can use the value of K to determine the speed of the car for different combinations of R's and cylinders. For example, if the car's been driving for 3 hours with a 6-cylinder engine, we can calculate the speed as S is equal to 15 k times 3 times 6, which caused us to get 270 miles per hour. So, in this example, the speed of the car varies jointly with the number of R's driven and the number of cylinders in its engine. Let's move on to number 2. Number 2. Solve for the value constant of variation, then find the missing value if m varies jointly as x and y, and m is equal to 60 when x is 5 and y is 6. So our equation will be m is equal to kxy. Substituting the value, we get 16 is equal to k times 5 times 6. So, simplify the equation, 5 times 6 is equal to 30. So, equation will be 60 is equal to 30k. Divide by sets by 30, cancel out 30, then 30 divided by 60 is equal to 2. So, our k will be 2. 2a. Find a when x is 7 and y is 6. Again, the equation will be m is equal to kx5. Substitute. M is equal to 2 times 7 times k. Multiply those to get m is equal to 84. 2b. Find x when m is equal to 72 and y is equal to 4. Again, our equation is m is equal to kxy. Substitution. M will be 72 is equal to k will be 2 times x and times 4. 4 times 2 is equal to 8 times x is 8x. So our equation will be 72 is equal to 8x. Divide both sides by 8, cancel out 8, then 8 divided by 72 is equal to 9. Again, I'm James Santoni Alcalda, your garden reporter for today. I hope you have learned something for today's class. If the gas price is 56, the price of good is 4. Again, our equation is G is equal to G. Combined. Combined variation. This is the word. The word. Now we know. Let's move on. Let's suppose that Gene is a creative product for small business. You may consider these 3 things. Needed M, capital C, and number of materials needed N.
Huh?
Number of materials M.
Number of materials needed M, number capital C, number of materials needed M. Umulit ka.
Yeah.